it's Actuary Dude here, looking at another exam question. So it says here, an insurance company has issued life insurance policies to 1,000 individuals. Each life has a probability Q of dying in the coming year, and in a warm year, Q is 0.001, and a cold year, Q is 0.005. So the probability of a warm year is 50%, and the probability of cold year is 50%. Let N be the aggregate number of claims across the portfolio in that coming year. So the first thing, it says calculate the mean and variance of N, being the aggregate number of claims. So the mean of N, basically, and this is straight out of the textbook, is the expectation of that conditional mean, that conditional expectation, N given Q, depending if it's going to be hot or cold. And in order to find that one, it's very easy. It's just, we have Q the first time of 0.001, and the chances of that happening is a half. And we also then have Q of 0.005 from here, and the chances of that being the cold year is a half, and that'll give us some figure for the mean. With the variance, there's a few more steps that's got to be taken. So to just find the variance of N, we need to find the variance of the expectation of N given Q. So it's basically the variance of this whole bit. And we're also going to add on the expectation of the variance of N given Q. So we have that bit there. So there's two things we need to just add together. So first bit, to find the variance of the expectation of N given Q, we can basically use very close to this formula. Now this bit over here, actually, sorry, I should have included, because that won't look right. We have to times that by 1,000 over there. When we multiply that by 1,000, that's the number of policies that we've got, and that'll tell us the expected number of claims. Whereas with this bit, because this first bit over here is the expectation of Q by itself. So let's first find the second moment of Q. So we're going to be taking this bit squared, so Q squared times the probability of that, and then we have the other one squared, 0.005 squared times a half. Okay, and that right there is the second moment of Q. Then we're going to be minusing this bit, so I'll just say that's the expected of Q, and I'll just include that there, all squared. Okay, and this is E of Q squared. Then once we have that, then we can times that whole bit by 1,000 squared, because we're trying to find this of N. These are the aggregate claims, and when we've got a variance, sorry, this is the number of policies written. When we've got a variance, we square it. We can't just multiply it by 1,000 like we did here. So that's the first bit, and the second bit is saying the expectation of the variance of N given Q. And in order to do that, by looking at the question, you can see that this is obviously a binomial distribution. There's two different outcomes. You either live or you die. And in order to find the variance of that, it's N, P, Q. It doesn't really matter which one we call P or Q in this case, because one's one minus the other. So in order to find that, we've got 1,000, and I'm just going to take it out as a common factor and say we have P for one of them, or Q, doesn't matter, 0.001, and we're timesing it by 1 minus that, which is 0.999. And that is a chance of a half to come up. And then we've got the other one, 0.005 times 0.995, which is 1 minus 0.005. Again, it's got a chance of a half to come up. That covers the full probabilities that it could be, and that'll give us a figure there. When we add these two together, that'll give us the variance of N. So let's calculate that now. All right. First bit, let's just find the expectation of Q, which is 0.001 times a half plus 0.005 times a half. And then we're multiplying that by 1,000, which gives us the expectation of N. And so we have 3. Now let's find the variance bit. And we're going to say we've got 0.001 squared times a half plus 0.005 squared times a half. And that gives us the second moment of Q. And in order to find the variance of Q, in that case, is saying this bit over here, our second moment, minus our first moment squared, which gives us this, and then we times that by our 1000 squared, and that gives us the variance of the expectation of n given q. So that's important. And then for the second bit, we're doing this bit over here, the expectation of the variance of n given q. So we'll start with n, we times it by everything, and then we've got n times p. So we've got, p times q, which is 0.001 times 0.999, and that's got a chance of a half to come up. We've got our 0.005 times 0.995, and that's got our chance of a half again to come up, which gives us this 2.987. When we add them together, gives us, this is the figure that we want, 6.987. So we've got 3 and 6.987. So let's write that down. That's 3 over there, which is the mean of n, and 6.987, which is the variance of n. Okay, so first bit done. That should hopefully cover a lot of the marks. Then it says to calculate the alternative values, so do it all again for mean and variance of n, assuming that q is now constant at 0.003. So that should hopefully be a quick thing to figure out. And so in an alternative world where we're not relying on the weather, 50-50 being hot or cold, saying the expectation of n is 1000 times this, q of 0.003. And that one should easily be able to work out in the head, which is 3. And then we have our variance of n, which is going to be straightforward. It's just going to be npq. 1000 times 0.003 times 1 minus that, which is 0.997. I don't know what that one is off the top of my head, so I'll just work that one out here. Equals 1000 times 0.003 times 0.997 gives us this 2.991. Okay, so let's write that one down. 2.991. So just coming up for me. .991. There we go. And now that we've done that bit, let's see what the third bit says. Comment on the results of I and double I. Alright, well, the means seem to be the exact same. That's not much of an issue. But then it's saying, okay, well, we've got a much higher variance over here for the first one that we did. And then we've got a much lower variance over here. What's the deal with that when we've got the same means? Well, the reason for that is basically because one is relying on the weather. And if it's going to be a warm year, there's not going to be many deaths. There'll be an expected of 1 death in that year. If it's going to be a cold year, we're expecting about 5 deaths. So it varies a lot more. Whereas in the other one, it's quite a bit more constant. Of course, a lot less variation because it is not reliant on the weather. Therefore, we don't have, I guess, as much varying deaths. And that should suffice to be the answer. So thanks for watching, and let me know if you've got any questions.